For problems 7 to 9. Okay, 7 to 9. So this is problem number 7. Katulad lang ng mga naunang problems, okay? PVMRT relationship, sa alamin mo lang ulit yung volume ng tank, i-determine mo lang yung hinahanap dyan. So this is the problem. A compressed air na naman, is confined in a cylindrical tank 1.5 meters in diameter. It is to be maintained at a temperature of 11.5 degrees Celsius and the pressure gauge of 11.5 bar. Ayan. 1 bar is equal to 100 kilopascal. Okay? Another keynote. Calculate the required length of the tank in feet if the maximum mass of the air is 211.5 kilograms in feet. Okay? Mamaya na tayo mag-convert. Lahat yan mostly naka SI units kasi ang bar is in SI units. So, lista ulit natin yung ating formula. Using PVMRT relationships, we are required to get the length of the tank. O, lista mo, PV is equal to MRT. Where V, yun ang kukunin natin sa V. Nandyan yung length. And cylindrical yan. For the volume of your cylinder going back to your solid mensuration days, that is equal to pi over 4 D squared L. Ito yung required, okay? L. Lista natin dito, P multiply to pi over 4 D squared. I-isolate na natin yung L equal to MRT. Now, R is considerable na given yan. Matik kasi R yung given, okay? So, L ang hinahanap natin. O, isa-isahin ko na lang. I-algebra na natin. L is equal to M R T. Yung 4, iakyat mo dito. 4 MRT over P D squared. O, meron ka ng formula for L. Then, the rest, ang gagawin mo na lang, i-substitute mo yung mga required values. L, 4M. Ano ba yung M natin? 211.5 kilograms. Yung R ng air, 0.28708 kilojoule per kilogram degree Kelvin. And then T, ano yung temperature natin dyan na given? 11.5 degrees Celsius, kailangan naka-absolute. Plus 273 kagad. Divided by the pressure. Ilan bars yan? Naka-gauge yan. Okay, pag naka-gauge, lalagyan mo ng plus, di ba? Okay, naka-gauge siya. So, 11.5 times 100 kPa kilonewton per meter squared per 1 bar plus ilan? Atmospheric 101.325 kilonewton per meter squared multiplied to D squared. Ano yung given dyan na diameter? That is 1.5 meters squared. O, di isang pindutan lang sa calcu, alam mo na kagad lahat ng values. So, that is 4 times 211.5 times 0.28708 multiplied to 11.5 plus 273 divide by 11.5 times 100 plus 101.325 multiplied to 1.5 times 1.5 or squared natin. The answer will be 24.54. Kaya lang nakaano siya, feet dapat pala, naka-feet. Okay, di multiply natin ng ang lalabas kasi dito sa cancellation of units, kilogram, kilogram, 'to, kilonewton meter squared. Okay, length ang hinahanap. Kilojoule, kilonewton meter, cancel yung dalawang meter squared dito. Meter, 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 kilonewton and then kilonewton. Tapos i-multiply natin ng naka-feet, 3.28 feet per 1 meter times 3.28. May nakalimutan pa ako. May nakalimutan ako, yung pi. Yun, pi. Pi. Okay, dagdag ko na lang dito. Okay, 3.28. Uy, mali. Ayan, answer. Multiply natin ng 3.28. 3.28 feet divide by pi. Yun, 25.62 yung L. 25.6228 feet. Okay, that is for number 7. How about number 8? 28 kilograms of air undergoes isobaric process at an initial temperature of 28 degrees Celsius. A total of 28 kilograms mass and a total of 280 kilocalories of heat have been added per second. So Q. Isobaric process. Okay, going back here. Pag isobaric process, bibigay ko sa inyo itong notes na to, okay? So, in isobaric process, that is constant pressure. Okay? H. For isobaric process, tandaan nyo na ang H is always equal to, okay? H is equal to M C P delta T. Okay? That is H. That is Q. M C P delta H. That is heat. Okay? Bibigay ko lahat sa inyo itong notes na to. Okay, mag-alala. Now, you are given Q is equal to M C P delta T. Q is equal to delta H. Or simply, yung delta H mo kasi is equal to delta U plus work non-flow. Now, ang hinahanap mo dito is the work non-flow in kilowatts. Okay? 'Di ba? Kapag work non-flow, going back. Kapag work non-flow in your isobaric process, that is P multiplied to V2 minus P1. Kaya lang wala kang given yan. Commonly, pag work non-flow, you go here. Okay? Yung heat transfer mo is equal to delta U plus delta U plus work. Yang hinahanap mo non-flow, that is equal to delta H kapag isobaric process. Okay? So, going back. Okay, work non-flow, hinahanap mo is equal to delta H minus delta U. Where your delta U is equal to M C V delta T. Okay? Meron kang air. Yung kilocalories naman, kcal. Anong unit ang natin diyan? Ang kcal. Kcal. Anong unit ang dapat nating gamitin dito? 1 kilocalorie equal to 4.187 kilojoules. Oh, yan ang ating conversion unit dyan. Okay? Oh, simplify natin yung work non-flow is equal to mCp delta T minus mCv delta T. Yan, okay na? Pwede nating ilabas si m delta T. Okay? Cp minus Cv. Pansin nyo, common kasi si m, si delta T, sa dalawa. Inilabas ko na lang. Pero makita nyo, m delta T, ano yung Cp minus Cv? Going back doon sa binigay ko kanina. Okay? Asan na ba yung binigay ko kanina? Ayun. Ano ba yun? Cp minus Cv is R. Ayun. R. That is equal to m R delta T. Okay? Pero solve na natin, okay? Na-solve na natin yung work non-flow. Paano gagawin ko dyan? Paano gagawin ko? I-solve ko muna si Q. Okay? I-solve ko muna yung M delta T. Hindi ko alam yung M delta T, okay? Sa M delta T, Q over Cp. Have been added in work non-flow. Work non-flow. Cp. Ay, mayroon na pala. Have been added per second. Okay? Hanapin ko si M delta T. Yun yung result natin dyan. Okay. M delta T. 28. Initial temperature. Wala tayong final temperature. Ayun. Okay, wala tayong final temperature sa delta T. Hanapin ko na lang muna si kaling kay Q. Q is equal to M Cp delta T. Okay, or Q is equal to M Cp T2 minus T1. Simplify ko na, hinahanap ko si T2. Meron tayong M, meron tayong Cp, meron tayong Q. Q over M Cp equal to T2 minus T1. Ngayon, itong hinahanap ko si T2. O, translate natin dito. T2 is equal to Q over M Cp plus T1. Lahat yan dapat naka absolute value. So, Q is, convert ko muna, kcal yun 280 kilocalories per second. 280 kilocal per second. Divide by M. 28 kilograms. Yung Cp is air 1.0062. Yan na. Equal to T2. Ano yung T2 natin dyan? Hindi, T2 pa lang hinahanap eh. Plus T1. T2. Kaya lang naka-kilojoules to. Dapat T1. T1 is 28 degrees Celsius. 28. plus 273 degree Kelvin para ma-cancel yung Kelvin. Kcal. Okay, dapat 'to naka-kilojoule din. So, 1 kilocalories, 4.187 kilojoule per kilocalorie. Cancel the same units, T2 is yung pala nawawala sa atin, T2. So, that is 280 times 4.187 divided by 28 times 1.0062. Dapat sakto 'to, pero 'pag board exam ang ginagamit dito 1 na lang, kahit wala na yung 0.0062. 28 plus 273. That is in what? Kelvin. O di minus ka na lang ng 273 para makuha mo yung degree Celsius. 69.612. 69.612 Kelvin, hindi na pala, degree Celsius. That is T2. Ngayon hahanapin mo naman si work non-flow. Work non-flow is mR delta T. Meron na tayong T2. Okay. 28 kilogram per second multiplied to R ng air, 0.28708 kilojoule per kilogram degree Kelvin. Tapos T2 is 69.612 minus 28. Pag change in temperature, matik yan, degree Kelvin na agad. Hindi pala pwede yung kanina na tinuro ko yung diretso. Kailangan dadaan ka pa rin. Okay? So, tignan natin kung tama. 28 times na kilowatts, di ba, ang hinahanap? 0.28708 multiplied to 69.612 minus 28. Ang lumabas dito, kilojoule per second, 334. Okay. 334.4872 kilowatts. Pag ganito mga type ng question, hanapin mo muna yung pinaka-root ng equation and then hanapin mo yung value na wala doon sa equation na yun. Tulad dito, ang hinahanap natin is T2. Wala ito. Okay? Meron tayong kumpleto. Pwede rin naman tayong dumiretso, sir. Saan? M delta T. Okay? M delta T kaagad ang hanapin natin kasi meron naman tayong CP. Ngayon, pag nahanap na natin si M delta T, ito, yung isang solution. Di ba meron kang Q is equal to M CP delta T. Okay. You don't have to mind yung yung equation na to. Yung hanapin mo na lang, okay? Ang hinahanap natin is work non-flow. M R delta T. Tignan mo yung dalawa. Ano yung common? Di ba M delta T? Okay? Kahit hindi mo na alamin yung value. Meron ang value ni Q. Ito yung shortcut Ito yung shortcut. Q, divide mo na lang CP. That is equal to M delta T. Okay? Gets nyo? Meron na tayong value ni M delta T. Ngayon, makukuha natin M delta T, pero yung M delta T na ito, pwede naman natin ipasok sa work non-flow. Yung work non-flow equal to Q over CP multiplied to what? Meron tayong M delta T. Multiply mo na lang kay R. Check natin, okay? Yung shortcut na ginawa ko. Yung Q, that is, kung di ako nagkakamali, ulitin natin Yung Q is 280 kilocalories of heat per second. 280 kilocal per second. Okay? I-divide mo ng CP. 1.0062 kilojoule per kilogram degree Kelvin. Okay? I-convert mo to, multiply mo ng conversion niya. Anong conversion nito? 4.187 kilojoule per kilocalorie. And then, i-multiply mo ng R ng air. 0.28708 kilojoule per kilogram degree Kelvin. Ito na po yung shortcut nun. Pinakita ko lang sa inyo yung long method. So, kilojoule per kilogram, kilojoule per kilogram. Magiging itong dalawa is kilowatts. Solve natin. Tingnan natin kung maging equal dito 280 times 4.187 times 0.28708 divide by 1.0062. The answer is the same. Okay? Yun yung shortcut. Madali. Di ba? Pag gagamitan mo lang ng algebra, makukuha mo yung shortcut niya. Okay, that is the shortcut. Algebra lang ang shortcut niyan. So, for number 9, an ammonia weighing 21 kilogram, ito na naman, paulit-ulit. Okay? Ulit-ulit na lang yung ating problem. So, ammonia. Ammonia is, methane kasi is CH4. Ammonia is NH3. This is methane. Alamin nyo to methane. NH3 is ammonia. Alamin nyo yung dalawa. Ammonia weighing 21 kilograms is confined inside a cylinder, equipped with a piston and has an initial pressure of 308 kilopascals at 34 degrees Celsius. If 2,500 kilojoules of heat is added to the ammonia, added, until its pressure and temperature are 308 and 110 degrees Celsius, respectively. What is the amount of work done by fluid in? Work done by the fluid. In a system, tandaan mo, okay? Ito yan, copy na natin. In a system, nasa baba. Kapag sinabing work done on the system, that is positive. Okay? Kapag sinabing heat added to the system, that is positive. Otherwise, kapag sinabing work is done by the system, you taken out the work, okay? That is negative. And then the heat is given off by the system, you take out the heat, that is negative. Okay? Number 9. Work done by the system, okay? Pag ginawa sa system mo, work is positive. And then the heat is added to the system, Q, that is positive. Okay? Otherwise, if work is taken out of the system, that is negative. And if heat is taken out of the system, that is negative. Okay? Yun, system. Yun lang kadali yun. Anong inahanap natin dito, sir? Okay? The work steady flow or work non-flow? Confined inside a cylinder. Is that steady flow or non-flow? Pag sinabing confined inside, that is an isolated system and that is a closed system. Therefore, the work here is work non-flow. Okay? Going back. Kapag work non-flow, okay. Work non-flow, that is, ito yung formula mo. Okay? Tama ba? Hindi, work non-flow. Ayan. For work non-flow, volume ang nagbabago. Okay? Then, pag work steady flow, the volume is constant and then pressure is parang baliktad. Parang baliktad ako dito. Check na natin. Okay, yun. Tama. Tama siya, tama. Okay. Work steady flow. Ayan. Pressure nagbabago. Work non-flow. Volume ang nagbabago. Yan. So, for work non-flow, you are given the pressure and then the volume changes, V2 minus V1. where that is also equal to the ano 'to, 'di ba binigay ko yan kanina? That is the change in enthalpy minus the change in internal energy. Okay. I-derive ko yan, 'di ba? So, P2 tuloy. P V2 minus V1 is equal to M delta T multiply to Cp minus Cv, where Cp and Cv is equal to R. Okay. Mr delta T. So, the work non-flow here is equal to, meron ka namang M, meron kang delta T, meron kang R. That is galing kay ammonia. Okay? NH3. Okay? Meron kang M, that is 21 kilograms of ammonia. Yung R mo, hindi mo alam, 8.3143. Divide mo na lang molecular weight. N, ilan ang N dyan? Isa, that is 14. Plus, H3, ilan ang H3? 3 times 1. Ang unit nito lalabas kilojoule per kilogram, degree Kelvin. And then, you multiply it with delta T. Tignan mo. Okay. So, 100 degrees Celsius and then 34 degrees Celsius. Degree Kelvin na to kasi change in temperature. Now, we can get the final answer. Cancel mo natin yung same units. Kilojoule, kilogram, degree Kelvin, degree Kelvin. Kilojoule ang hinahanap dyan. So, that is 21 times 8.3143 plus 7, divide by 17. 3143 divide by 17 multiplied to 100 minus 34, I think that is 66. The answer is 677.8599 or 86. Simple ganun na lang. 677.86 kilojoules. That is the answer for number 9. Let us take another 5-minute break. Okay? Oy, tapos na pala. Number 10 muna. Solve na lang natin number 10. Saglit lang naman na number 10. So, a closed vessel contains air at an air pressure of, closed vessel na naman, pressure of 180 kPa gauge and the temperature of 18 degrees Celsius. Find the final gauge pressure in kPa if the air is heated during an isometric process to 81 degrees Fahrenheit. The atmospheric pressure is 101.8 kPa. So, meron kang T1, 18 degrees Celsius. P1 is 180 kPa kpag. Tapos meron kang atmospheric is ito. Meron kang T1. T2 pala. T2, 81 degrees Fahrenheit. And then, ang hinahanap mo dyan is P2. Final gauge pressure. Madali na yan. Sinabi dyan that using your combined gas law, P1, V1 over T1 equal to P2, V2 over T2. Ngayon, di ba sinabi dito that it is isometric process. Ibig sabihin, pag isometric, V is constant. So, might as well i-cancel mo yung V. Okay. You will arrive with what? You will arrive with this. P1 over T1 equal to P2 over T2. Now, we are asked to find P2. Okay. P2 is equal to P1, T2 over T1. Okay, pwede natin isulat yung mga value. So, P2, in gauge to gauge. So, P1 is in gauge, pero dapat to parati mong ilalagay muna bago mo gawing convert yung dulo ng gauge. Gawin mo muna siyang absolute. So, this is 180 kPa gauge. 180 kPa plus yung atmospheric, ayun o, 101.8 kPa. And then, yung temperature 2, that is 81 degrees Fahrenheit. Convert ko na, sir, siya. Ano bang inaanap dito? Mhm. Final gauge pressure in kPa. Convert ko na agad to, yung 81 degrees Fahrenheit to degrees Celsius. So, that is dito, shift 3, 7. Shift, convert, 37. Degrees Fahrenheit to Celsius, 81 to. That is 245 divided by 9. 245 divided by 9 plus 273 degree Kelvin over over T1. What is T1? 18. Check natin na. 18 plus 273 degree Kelvin. Ngayon, sir, ang hinahanap natin dito kasi is in what? Is in gauge. O, di minusan natin nung atmospheric 101.8 kpag. kPa para maging kpag na 'tong lahat. Okay. So, P2 in gauge, 180 plus 101.8 multiplied to 245 divided by 9 plus 273 multiplied to 18, 18 plus 273. And then, minus mo ng, para maging kpag, 101.8. Now, the answer will be 188.9306. 188.9307 kpag. Okay? I think that will be all for this meeting. Let us finish this when we continue next meeting. Okay? Bye-bye. Bye-bye. Bye-bye.